All right. Hi, everyone, and welcome to the Using Empirica for High Throughput Virtual Experiments event. I'm here today with the rest of the Empirica team, including Nicholas.
Hi there. I'm the lead developer on Meteor. Been working with Abdullah at the start of the project a couple years ago, and still the main maintainer of the code.
And we have also James.
Hi, I'm a PhD student at MIT working on my thesis, and I'm using Empirica as to test some of the theoretical predictions I've done in some simulation work.
And we have also Joshua.
Hi, I'm Joshua. I'll be an assistant professor at University College London. As of next week, I'm an avid Empirica user, and I'm happy to take any tech questions or how-to questions, no matter how simple. I'll make sure everybody has my contacts later.
Perfect. So on behalf of the rest of the Empirica team who could not join us also today, we welcome you. And let me start by telling you briefly about our plan for today. So we asked you to watch the pre-arrival materials because we plan to build on where the tutorial left off. So I hope many of you had the chance to actually go through some of these tutorial videos. But also we limited the registration for these sessions so we can make them a little bit more interactive. So we would encourage you to use the chat to comment and ask questions throughout. Also, for any urgent and burning clarification questions, please feel free to raise your hand or send a message to Joshua, or even unmute yourself and interrupt the speaker. So don't hold back. But please note that the session is being recorded. So just to start by introducing yourself, saying who you are, and then you could ask the question. And all of you are, have the ability to unmute yourselves. So also we will be asking some simple questions that require show of hands. So if you are comfortable, we would appreciate if you could keep your camera on so you can raise your hand physically and answer those questions, and also to make it a little bit more interactive for us. So today we're going to start with me for very briefly telling you about Empirica and how to think about it and how to, some of the motivations and kind of design aspects of the platform at very high level. And then we will take you through an interactive demo. So the idea of the interactive demo is not to really have you ready to run your own experiment after the session is end, but to expose you to different aspects and components of the tool from various perspectives. So you get a feel of how to actually develop and run an experiment using Empirica. So this will include designing the experiment. So from the perspective of the researcher, how can you think about your questions and how can you actually design an experiment within the language or the framework of Empirica? Then to implementing your experiment, and that's kind of where the development goes on, and a lot of the tutorial and pre-arrival material were about that. Then there is the deployment, which is how do you expose now your developed or implemented experiment to the outside world, so participants and subjects can take part of your experiment, to recruiting participants. And here it can be different based on how you plan to recruit your participants, but we will do it through Amazon Mechanical Turk for synchronous and real-time interactive type of experiments. Then to actually from the subject or from the participant perspective, you'll take a part of an existing experiment and experience that perspective. And then finally from exporting the data and analyzing it. So going back to the researcher perspective of things. And at the end, we are going to have a session for Q&A to answer any general questions or questions about your particular the particular experiment that you are thinking about, or anything related to Empirica or online experiments in general, or the future of experimentation. So it's really going to be open-ended. So with that, let me just introduce a framework that I think is helpful to evaluate or think of the different tools that can help you to run your experiments. And I think one good way to think about it is through this usability, flexibility space. And to make this a little bit more concrete, think of something like Qualtrics. So if you want to run an experiment with Qualtrics, it's quite easy to do within a couple of hours, even if it's the first time that you've heard of Qualtrics, you will be able to get something up and running and it's working. It's mostly a graphical user interface. But then, so this has high usability. But then at the other hand, it has very little flexibility. So it's great if you want to run survey experiments, but if you want to run any other types of experiments, even if it's a simple two-player economic game like Prisoner's Dilemma or sequential decision-making or simultaneous decision-making, then it becomes very hard to do. And then you will have to compromise on the design of your ideal experiment in order to be able to fit it within what Qualtrics allows you to do. On the other hand, you can work, or on the other extreme, you could work with a real professional software engineer. In principle, if you go with that option, you can implement anything you have in mind. So whatever design, anything that can be done on a browser, and even not necessarily on a browser, anything on mobile or anything else, you can, in theory, do and kind of have the implementation for the optimal design to answer your research question. But then that is very costly. It's time consuming. And there is additional communication cost that is associated with this approach, that due to the fact that many of the software engineers are well aware of the best practices of building software, but not necessarily of experimental design. And researchers are really trained methodologists who knows a lot about the best practices of designing and running experiments, but not necessarily architecturing or developing code or software. And then there are a bunch of other tools that are somewhere in that space, right? So there are some tools where the origin or platforms that are developed for particular use cases, like for simple behavioral economic games, or like something like for sequential decision-making or simultaneous decision-making. These tools allow you to kind of start very quickly and develop something that works, but it's kind of constrained. So it doesn't allow you to do anything you have in mind. It's constrained by what the original developers of this platform had in mind. And the goal of Empirica when we started it, which actually was born during the second week of the Summer Institute in 2017, when we wanted to design, as part of our project, we wanted to design and implement an experiment, and we realized that we couldn't actually go from design to a prototype to actually recruiting participants and running some pilots within a week because of this trade-off. So immediately afterward, I was lucky to meet Nicholas, and then we started this project, which is how can we actually break off from this trade-off? How can we design a platform that actually gives you high flexibility such that researchers can design experiments that we couldn't imagine ourselves, the platform developers, but at the same time make it as easy such that anyone with a little bit of JavaScript experience or some programming experience, they can actually hit the ground running. And we kind of try to break off from this usability flexibility trade-off through a combination of what we call flexible defaults, design strategy, and an architecture that explicitly separates experiment design from administration, from implementation. So we have a recent preprint that's currently on arXiv that describes in detail how the system works and how do we kind of envision it breaking off from that trade-off. So the position of Empirica on that here is a little bit more aspirational there rather than where it actually is, but kind of we are building towards being there. And let me focus on one of the two aspects. So I said flexible defaults. That's kind of just by thinking really hard about how can we provide a scaffolding that allows people to get started very quickly, but at the same time not prevent them from deviating from those defaults and designing anything they have in their mind. But the second part that I'm going to talk a little bit more about is the explicit separation of experimental design from administration, from implementation. So when I talk about experiment design, Empirica actually provides you with a way or a view that allows you to make decisions. So this is usually typically by the researchers about the design of your experiment. So you parameterize your experiment. You actually make all of the decisions about all of the variables involved in this virtual environment. And you make decisions about what values these parameters are going to take in your experiment. And then this allows you to really, once you define the entire space of possible experiments given your design, you actually can sample or decide which parameter choices or values you want to actually run and potentially systematically vary to test your favorite theory. And what happens in the back end, we introduce this concept that we call it an experiment as code, which generates these user-friendly but machine-readable YAML files that log everything about these decisions. So in that sense, you are not only sharing the data from your experiment, but you could share and have a version control and a history of your data generation process, all of the decisions that you've made and all of the parameters that you operationalize and what values you actually selected. And the benefit of actually encoding experiments, so the entire experiment design as code, is that these decisions, they don't necessarily have to be done by humans. So typically researchers are the ones that are going to select and make decisions about these parameters, but you can imagine having an algorithm that will make decisions about which treatments, which conditions to run based on prior trials and some data, so ongoing trials and data collected in real time. But also you can have procedural generation or ways to actually explore the entire parameter space of your experiment in a more systematic manner. So that's kind of on the design. So that requires almost no coding. It's just making decisions about the experiment that you are going to run. The second part is the experiment implementation or development, and that's what you've all seen or experienced by going through the video tutorials that we asked you to walk through. And basically, we provide this flexible abstract API that allows you to make decisions and implement the logic of your game given a design that is provided to you from the experiment design component. Then there is the experiment administration, which includes the starting of experimental trials, ending experimental trials, and observing experimental trials as participants join and take part of your experiment. So with that, I'm going to hand it off to James now, who's going to take you through all of these steps and the interesting part of this session.
Great, and I'm seeing a couple hands. Nicholas, you have a question?
Yeah, excuse me. Thank you for the introduction. I was wondering, and maybe this is somewhere in the, in the files that you guys send around, but it's been a week or so with a lot of input, so I may have forgotten. Is this free to use? And is there a cap on the throughput of, let's say we get lucky and a lot of people want to participate in our experiments? Is there a cap on that? And then, I guess connected to that, so would it be possible to use this in a teaching environment with, all these students making accounts and programming an experiment?
No, this is a great question. So let me answer the first one. And I think the second one might be better answered when we talk about deployment, which is about the throughput and how it scales. So the first question is whether it's free to use. So yes, Empirica is an open source project. All of the core code of Empirica is open source and it's publicly available on the GitHub repo. But also it is, we encourage people who build experiments with Empirica to make their experiments also publicly available. And we have a section on the website for the community demos. So you can see their different experiments that are implemented by different people. And it is well suited for teaching environments as well, for students to actually implement their own experiments, but also to run experiments with students. So actually to run an experiment and have the participants be the students themselves, and then allowing them to see their own data and also to analyze it and see what happened in these experiments, which is going to be very similar to what James is going to show as part of the demo. For the scalability question, let's kind of put a pin on it and come back to it when James reaches to the deployment aspects, because that's where the scalability questions will be answered anyway.
I just want to add a question to that I think is sort of implied, and maybe in some people's minds. Abdullah, will this ever be a commercial enterprise, or can we think of this more as just a service to the community? I mean, you talked about these kind of cutting edge experimental methods. Is that what this is about?
So it's going to remain open source forever, as in the main offering of Empirica and of the core code, and how even in future versions. So something maybe we'll talk about towards the end is what is the future of Empirica and where it's heading, and how do we envision the future of online experimentation beyond the replication of in-person physical, like the paradigms of physical lab experiments, to actually envision new paradigms and new ways and cutting edge methodologies of running experiments. And even those future iterations and versions of Empirica will remain free and open source forever.
Great. Well, I guess I'll go ahead and get started. So just a brief bit of introduction. I am in the last year of my PhD program at MIT. My thesis defense is scheduled for July 24th, so I have a lot of work to do between now and then. And what I'm going to show you today is basically the last part of my thesis defense and how I'm using Empirica to make it possible. So the first thing I'm going to show you, if I can successfully share my screen, I had a little bit of trouble with this last time. I want to share this one. Great. So the question that my thesis asks is, it's about interactions between ideas that are spreading through social contagion in a population. So first I want to tell you about how we currently think about social contagion. And we basically take our ideas from epidemiology. We say that there is something that is spreading in the population, and if you are susceptible to it and you are exposed to it, then you may adopt it and share it with your friends. So here's an idea that spread through the population on June 18th, 2015, which was the announcement that the Treasury would put a portrait of a woman on the $10 bill. And here's another belief, which was also spreading on the same day. Another piece of information was that a white gunman had opened fire at a historically black church in Charleston, South Carolina, killing 9 people. Now, traditionally, when we study the spread of these things, we can look at them one at a time. And the reason for this is that we don't really think there's a whole lot of reason why your previous exposure and belief in the relevance of the information about the woman on the $10 bill, and we don't think that should influence your likelihood of believing that the shooting in Charleston, South Carolina was relevant and worth sharing as well. So we can talk about these as independent, in that your adoption of A doesn't change your susceptibility to B and vice versa. And this is really useful because we can study the diffusion of things independently and then just sort of linearly superimpose them on top of each other. Now here's an example of where that doesn't really hold. Here's another message that went out the day following that shooting, which was a piece of information which identified the shooter with the Confederate flag. And this is the shooter self-identified with this flag. And at the same time, spreading through the same population was information that the Confederate flag was still flying over the South Carolina state capitol grounds. Now, if you have been exposed to one of these pieces of information, you're more likely to think that the other is politically relevant and worth sharing. And so we can't think about these as independent anymore. We have to think about them as interdependent, in that your adoption of A influences your likelihood of adopting B. So the question is, what does this do to our understanding of social contagion? So I'll share with you a little mechanism which kind of illustrates what can happen when we're using our existing beliefs to decide what to do with beliefs that we're exposed to. So here are 3 friends, Joe, Ellen, and Susanna, and they have some beliefs. So they think that the shooting was a case of racial violence and the Confederate flag is a symbol of racial violence. And they have some similarity with each other because they share these beliefs. Now let's say that Ellen adopts a new belief that she's been exposed to, that the Confederate flag is flown by the state government. And then she goes on and shares this with Joe. So what does this do? It actually increases the similarity between Joe and Ellen, and it decreases their similarity with Susanna. So now what happens when somebody else comes along and says that the state government endorses racial violence? So Joe and Ellen, having these new beliefs, are more likely to adopt that belief than Susanna is, because if they're using their existing beliefs to make a decision on that new candidate, this belief that they now share in common is going to influence their decision. And so what we actually see here is that their increased similarity causes them to behave in the same way in the future and become more similar. And it actually decreases their similarity with others even further. So we have this dynamic of agreement cascades, where the more similar you are, the more similar you can become. So what does this actually do? When we put this into an agent-based model, and we sort of say in one world in our agent-based model, let's look for this interaction between beliefs, and in the other world, let's have beliefs be independent of each other, as the existing literature expects. The first thing we see is that the most similar individuals, who are within camp, if you will, become even more similar. We also see that the least similar individuals become even less similar, so your distance to somebody in another camp grows. And lastly, we see that it's easier to describe this population as aligning along some left-right axis. So we talk about a political spectrum in the United States, and we can see these political spectrum emerge in this agent-based simulation. Now, the task of the experiment that I'm going to share with you today is to see whether these results that are predicted from the agent-based model will actually hold with real human actors, as opposed to with simplified models of humans. And we do this in an experiment for two very important reasons. One is that if we were to do this type of experiment in the real world with human beings in their natural context, we have issues of bias where people are already have ideas that they're going to bring into this experiment. And so we won't know if the polarization we see in the experiment is due to our manipulation, or if it's actually just due to the bias that already exists in that population. The other thing that we see in the real world is that there are social network structures which already encode some form of polarization, as I have a circle of friends who's close to me and I'm more likely to be like them, and there are other people out there in the world who I'm less similar to. So in a virtual lab setting, we can actually abstract both of these by specifying what the social network structure is going to be, so we can minimize the bias, the polarization we should expect from that. And we can create an artificial informational environment as well, where all the things that are happening in the experiment are constructed for the purpose of the experiment, so people's external biases from the outside world spill over as little as possible. Make sense so far? Give me a thumbs up. Great, thank you. Okay, so online multiplayer game. This is where Empirica comes in. So in my game, what we're going to do is we're going to recruit participants from Amazon Mechanical Turk, and we're actually going to do this today. So you guys are going to play the game, and there are 20 of us, and there are 40 slots in the game. So I've recruited a bunch of Turk workers who are going to join us. So our deadline for that is 10:45. And we're going to go into 2 social networks. So there'll be, each social network will have 20 players, and the social networks will be identically constructed, and we'll just randomly assign people to each of those roles in the 2 games. And then what we'll do is we'll ask everybody in these 2 social networks to solve a mystery. And we'll do this by sharing them some clues that they may use to infer what happened in this mystery. And they'll share the clues that they think are true with their neighbors in the social network. So there's this process of social contagion where you're exposed to a clue, which is going to be our operationalization of a belief or an idea. You're exposed to a clue, and if you choose to adopt it, you might categorize it as a promising lead. And if you do that, then it will be shared with your neighbors in the social network. So this is a bit what that will look like, and you'll get to play this in just a few minutes. So first of all, individuals are taking clues they think are true and sorting them into the different categories. And as they do so, you'll see that their collaborators are actually doing the same thing. And so those notebooks are updating in real time. And this is something I could only do with Empirica because I need this real-time interaction over the course of 8 minutes as people are sharing these beliefs with each other. Now, let me tell you a bit about the manipulation. So what we want to do is we want to construct 2 worlds, one in which the clues relate to each other strongly, and the other in which the clues don't relate to each other. So what we do is I start with a crime scene and a stolen object, And to these, I connect 3 suspects, 2 items of clothing, 2 physical descriptions, 2 tools, and 2 getaway vehicles. And I can construct a clue by making a link between any of these 2 things. So I could say that Hayes was seen at the Daily Auction House. And then I can actually create links that connect all of these different pieces to each other. And so what you see now is I've constructed a whole set of clues which are independent of one another. And they're independent because nothing that you learn about Barnes will tell you anything about what happens with a blue blazer, whether or not the blue blazer is more likely or less likely to be used in the burglary or worn in the burglary. So if we want to create a world in which these beliefs interact with each other, what we do is we can create some cross-linking clues. So let's connect Hayes to Barnes, and then let's connect everyone to everyone else. So now we have a fully connected set of clues. Now, to create a control world, we want this to be as similar as possible to the treatment world, in that everybody has the same number of clues and the clues discuss similar topics. But we don't want those cross-linking clues to be present because we still want to maintain the independence between those clues. So Snyder was seen at the Daily Auction House as a clue that tells us about the crime scene. So we can keep that because it's independent of other clues in this context, the way I showed you before. Same with the burly man that had been seen with a diamond. But Snyder being described as a burly man is one of those cross-linking clues, which is going to create interdependence. So we want something to put in that slot that doesn't make a connection. So we'll just say that Snyder lives in Cedarville. And same with Hayes and the Jeep, we'll just say that Hayes has a tattoo of a bear. And what you'll see this does is it actually breaks those cross-linking clues so that now we see that Hayes works on the North Shore maybe, and we can break all of the clues in this set. There you go, fancy animations. So that's the basic overview of the research question and the sort of experimental design. Any questions on that point so far? Joshua, we had anything in the chat?
Nope, but I think you might be getting this, but at some point, I assume, are you going to translate like that network into, text files and data and stuff?
Yeah, we can do that. I'll show you how that's built up. Let's do that right now, actually. Let me pull that up for you. And I'll show you, actually, no, I'll do this in a little bit when we get to the way the experiments are configured. So the next thing I'm actually going to show you is how I've deployed this experiment. So there are a number of different ways that we can deploy these experiments to the web.
Just as a reminder,
go ahead.
For context, is that now James, going from his experimental design, he implemented the experiment, which is something similar to what you've seen in the videos. But now it lives in your machine, and deployment is just the idea that you expose it to the outside world. And that's where scalability questions might come in. And now what James is going to show is how to deploy his experiment from his local machine to the cloud so other people can have access to it.
In fact, I'm going to add, I want to add even a more basic element that when developing these kinds of experiments, in order to sort of protect ourselves and make sure we don't make any mistakes utterly in the public, we usually have 2 versions. One of the experiment that we safely develop on our home computer and practice with browser bots or just logging in ourselves. And you basically do all of your work in that nice, safe environment. That's where all this design happened. And then we only, once we're comfortable, do we send it out to the web for people to actually interact with.
Thanks. Yeah, this is I launched this particular instance of the experiment this morning, so it's setting it up right before we actually want to run it. So what I actually did is I have a cluster which I've built here, and this is going to be a database which is going to store all of the data from our experiment. And this is running actually on a separate server from the experimental code itself. And this is a hosting server that's provided by MongoDB called Atlas. And what I can do is I can just say, I want a cluster of this amount, this size, and I pay pretty much by the hour. I can pause the cluster when I need to. And they actually have a free tier, so you can go ahead and start your experiment work without actually having to pay for a cluster. So you sign up for an account on it's mongodb.com, and then you'll come in here and you'll create a cluster like this. Now, I have a large experiment. We're going to run in some of my games 80 people running simultaneously. I'm going to have 100 to 120 people sort of entering at the same time so that I can get them through the training steps, and some people are going to drop out. So I have quite a large cluster built together, but you can do this with a much smaller cluster. So once I've set up the cluster, what I need to do is I need to get access to it. So the first thing I'm going to do is create some users who are going to be programmatic users of this cluster from my experiment. So I've got a user here called Detective Galaxy, and I've got another user called Oblogger. And they get passwords and they get permissions. So here, these folks are set up to have those permissions that they need. And then what I need to do is I need to say, let's let anyone access, or let's let this database be accessed by anywhere in the web. So this is whitelisting every URL. Joshua has a question.
Just wanted to translate that for people who aren't as familiar. When he says creating users, that's because even when a computer goes to access the database, that computer script needs to access it through some username. So this relates to all the different security layers that are what keep your data private and secure.
That's great. So now I'll show you what I do with these users. So this is my Empirica project. You've all worked through the tutorials that should get you to this stage. And in your tutorial projects, you had this local.json, which had some settings that you could use. So here's the password for the admin console. I'm also going to create one of these for publicly deploying. And so this is the same thing that you would see before. This is who should be an admin on the Empirica console. But then I've also got this piece which is telling Galaxy, which is going to be the hosting server we're going to use, how to connect to the database. So basically you get a URL, and then in this URL I've put the admin name and the passwords for those logins. And this is not the actual password, so don't feel like I'm showing you too much. And then you just tell it which collection in that database you need to use. So now I've showed you everything you need to know in order to get your experiment set up with this database. So now once you've created this folder, or sorry, this file, and you've put in these pieces, the next thing to do is to launch the experiment to the hosting server. So let me show you what that looks like. So the hosting server that I'm using is Galaxy, which is a service provided by Meteor, which is the framework that we're all using for Empirica. And once you've created an account here, you will generate some login credentials, and you'll sign up, and you have to pay for it, but it's not very expensive. So I think the cheapest is something like $9 an hour. Sorry, 9 cents an hour. It's very different. And the thing that you do is you just spool up the server when you're ready to run your experiment and run it. And then you stop the server after your experiment's done. So it's not that expensive. And then the only thing I need to do after that, after I've made my login credentials, is to run this command. So first I'm going to say that the host name that I'm going to deploy to is this Galaxy deploy, which is here. And then I'm going to give the command Meteor, which is the command we've been using to start our experiments. And I'm going to tell it to deploy to that hosting server. And then I'm going to specify the URL. So this is the demo URL for the demo game that you guys built. And then I'll pass it this settings file. So once you've done that, you're done. It takes about 15 minutes to launch. So I'm not going to do that for you now. And then you'll see something that looks like this. So this is the hosting page for the game that we're going to play together today. And you'll see that in this case, I'm running some large clusters, computers, to make sure that I have enough computing power. And it'll show you the number of connections to this database and the CPU usage and all the pieces that you need to make sure that your server's working well. And once you've done this, and it'll take 15 minutes or so to go through the logs, and it'll tell you that it's launched, then you're ready to go. So you go to the URL that you specified. So here for us, it's going to be detective.meteorapp.com. You add your /admin. And now we see served on the web the same user interface, the same admin interface that we did locally.
So let me make a comment and kind of just a recap of what James just did, which is basically you have your experiment in your local machine. So you have the code running on your machine, and also you have a database that is on your machine that is kind of keeping track of the state of your experiment when you were developing it. Now you have to expose it to the outside world. So there are two pieces that have to be accessible to the outside world. One is the database, and the other one is the code, the hosting of your actual experimental code. In principle, they could live in the same place, the database and the code, the same way that they were in your machine. So if you have a private, for instance, if you have a private server, or you have some hosting service that you like, you can just host them and then then people can use it directly. What we've shown here is just one example, which is the database is on MongoDB Atlas. The code lives in Galaxy. This just makes your life easy. And then all you have to do is to tell Empirica where the database lives and where to send the code. That's all that Empirica needs. It doesn't care actually which exact instance of the database or service that you are going to use. In the chat, I'm going to send also an alternative option, which is Empirica has its own Empirica deploy service, which is a way to actually host or deploy your experiments on Amazon Web Service. And it does all of the work for you, such that it's just you put in your credentials, you run 2 lines in your command line, and it will be uploaded. And that actually helps with scalability. So going back to the scalability issue that Nicholas brought up, with Galaxy and Mongo Atlas setup, you can run easily 100 simultaneous participants who are interacting in real time, so they observe each other's actions in real time with no latency issues. Once you increase the number of simultaneous participants, maybe you need 300 participants simultaneously across your treatments that are going to be interacting. That's when you hit the bottleneck, and usually it's Galaxy. It's the CPU. It's where your code lives, not the database. And if you get to that point, then using alternative services, something other than Galaxy or Amazon Web Service through the Empirica Deploy app will allow you to easily scale up to 300 participants. If you want to scale beyond that, then you need more powerful hardware. And there are a little bit more harder to deploy options that can scale all the way up to 1,000 simultaneous participants.
Great. So I'm using overkill hardware in this demo just to make sure we don't have any technical issues. And that's because hardware is always cheaper than a failed experiment. Great. So the next thing we're going to do is I'm actually going to send you to this URL. So what we need to do is we need to create a new batch so that you can actually go ahead and get started playing this. And I'm going to create a new treatment, and it's going to be, let's use this one here. So this is a treatment which I've created in an external YAML file. I have a Python script which creates that treatment. I can share that with you later if you're interested. And now our experiment should be live. So I am putting into the chat window right now the URL to this. And what I'd like you to do is everybody go to that URL and work through the consent and the training, and get to the lobby, and give us a note in the chat when you get to the lobby.
And James, just to check in while people do this, should we panelists be holding off? Are you going to fill in the gaps with mTurkers?
I'm definitely filling in the gaps with mTurkers. The mTurkers hit will arrive at 10:45. So if everybody gets to the lobby before 10:45, they should get into the game.
My thought is that if we panelists hang back, it increases the probability that the participants will get assigned to a condition.
Yeah, that sounds good. And I'm going to just be quiet for a bit to let you guys work through that and give it your attention. And actually, Joshua, if you wanted to, or what I'll do is I'll work through the intro screens just to show everyone what happens for those.
So we give some kind of email address here?
You can put anything, your name or just a random string, it doesn't matter. The mTurkers are adding their Turk IDs there.
So one thing also, like the place where it asked you to enter some identifier, if you integrate it with services like mTurk, so you are recruiting participants from mTurk, those that are arriving from mTurk, it will use automatically their worker ID as and that page will be skipped. And you can actually mix and match. So you could recruit people from Prolific and mTurk and volunteer participants at the same time, and Empirica will realize where they are coming from, and accordingly will use the appropriate one. If it has no ID for them, it will ask them to input something. One, I think it's a cool feature that you'll see is once you get to the lobby, you have a chat. So you can chat with other participants while you are waiting in the lobby for the game to start. And basically one thing that one reason for us to kind of add this feature, you can turn it on and off when you deploy your experiment, is that in many cases, people from Amazon Mechanical Turk, they don't believe that other participants are real people. They always think that they are being, that there are bots and that there is deception potentially in the experiment. And if you add the chat in the lobby and just look at the data that they generate, most of what they are going to do is trying to figure out if other people are real people or bots.
So James, you want to tell us what's going on with those gray and black little icons there?
Sure. So what you're seeing here, the gray icons tell us the number of people who are currently in training. So there's a number of you guys. And then the black icons are people who have made it through the training into the lobby. And in the lobby, you see the chat and the lobby message. So proceed until you get to that.
Can you tell us what you, or maybe in a minute, what's in your screen, like what's happening from the admin perspective?
What would you call out?
So what are these black icons, or did you just mention that one?
We just did that one. Yeah.
We just did this one. I was focusing on trying to pass your attention checks.
I'm glad they worked. Looks like we still got 6 folks working through the intro screens. That's fine.
For the people who do have some attention to spare, I'll comment. I was asking about who should log in because there's always an issue when running group experiments, getting the right number of people. If I want to run a group of 20 people, but only 19 show up, that's basically 19 people's wasted time. You know, you might have some flexibility in your scientific plans. So a good strategy is to invite a lot of people and, you know, hope you have enough, but then you need something to do with the extra. So a well-designed workflow will either channel people to a thank you page that pays them some token amount, or maybe you've got another experiment running you can send them to. So I was asking James about that earlier, because if I log in, that could take a spot away from one of you. Not something, of course, we're usually concerned about. Usually MTurkers are relatively fungible, but workshops add a little extra logic to consider.
So it is 10:45, and what that means is that the hit that I set up this morning is likely to be launching itself right now. And the way that I actually worked this is that I have done 2 hits already this morning where I recruited players. And what I did was I said, I'm going to be running this game at 10:45, and if you'd like to play, you know, complete this hit and tell me that you'll be there. And then that gave me a list of workers who said they could be available at that time. And then I set up this hit here. I'm using Turk Prime. And basically what you see is I've invited those workers to participate in the game, and they'll be sent to this this place already. And the other thing that I did was I set it up so that they received some email messages automatically this morning. So 15 minutes ago, I sent them this email which said, thanks for signing up. The hit is scheduled to launch in 15 minutes, and you'll receive an email link for this hit. And then if I refresh this, we should see that right as the hit launched at 10:45, another email was sent to them with a link to the hit, which is this message here. And I said, the hit you signed up for is now live. And I remind them that there are only a limited number of slots, and then they need to work through quickly in order to get a slot. And they know that some of them may not get slots. And they'll all be paid for showing up. And so now what we can see is that a number of them are starting to fill in. So if I reload this page, we can see the number who have accepted that new hit. So 33 of those who signed up, I had 50 sign up. So 33 are currently working through the intro screens. So now if I go back to the admin interface, I should be able to see them. So there's 15 people already in the lobby, and you're chatting away, I imagine. I don't have it open, so I can't see. And then there's 30 others who are still working through the training. So this is good because we need 40 for the game to launch. So we should be optimistic that that happens.
So Empirica by default provides a couple of options of how to configure your lobby, but also you can write the code of the logic of your lobby in any way that you want. So by default, you have an option which is when do you want the game start? And you can say, I need 40 people and then have the game start. But then there are a couple of options. What if I only get 30 people show up and they've been waiting for 10 minutes? What should I do then? You have an option for you to fail the experiment. So you just redirect everyone to the exit survey, tell them, sorry, we couldn't start the game. We didn't have enough people, and maybe you pay them something. You could start the game anyway. So maybe you don't care that the experiment requires 40 people. You're fine with 30 people or 33 or however showed up. So you say in 10 minutes, even if we don't have enough people, start anyway. Or you could fill the slots with bots. So you could have a behavior for a bot, and then you just tell Empirica that by this time, if the game does not start, just fill in the empty slots with bots. Or you could do any other also logic of the experiment. For example, if I have more people than I need, then one thing I want to do is for the surplus to be moved on to another experiment that doesn't require multi-participants, or to conditions where there are only solo participants. So you can always manage the logic of what happens when you don't have enough people, or if you have more people than you need.
Now, did anybody not make it into the lobby yet?
And if you need help with the attention checks, let us know in the chat, because I know that James's questions are pretty tricky.
Okay, I think what I will actually do is join the game myself, so that in the video we have a show of the game being played. So now you'll see me in my screen. I'm in the game.
One of the things I absolutely love about Empirica is these little things, like in the lobby, how it says like 38 of 40 players necessary. Because one of the really tricky things about running these group experiments is just managing all these people. It's like herding cats. So anything you can do from the moment you first contact them to the time the game starts to just manage expectations and channel information is really valuable. Okay, I'll let you clean it.
So James, does it make sense that your promising leads are different from the ones that I see on my screen?
Yes, we all have different promising leads.
Are these random?
These are drawn from a random pool, so there are 78 clues total, and you're randomly assigned one, and each clue is present exactly once. And then there's some fillers.
And if you wanted to come up with a completely different mystery and run this again, how would you do that?
I actually do this every time you run the game. It's a different mystery. And so I have a pool of suspects. I have a pool of all the rest of the pieces, and they can be randomly inserted into the game.
So do you have to, what mechanically are you doing to make that update? Is it just a matter of swapping out a file or a setting, or do you have to recode something on a deeper level?
I have a file which has all of the games built into it.
So I'm going to offer occasional commentary while we do this, but for those of you who are trying to actually focus on playing the game, do feel free to just give your attention to that. I'll just, as I'm looking at James's screen, I'll just remark that one of the things that's going on here that I think James mentioned during the setup is that there's two main kind of configurations. They're both networks in a sense. One is the semantic network, so that's the mystery. And if you want to make a new mystery, you just upload a new file with the configuration details, and based on the way James has built the game, it sounds like it'll just read that right in. And the other network that's going on here is this network of clue sharing. So looking at James's screen, they've got collaborator 1, collaborator 2, and collaborator 3. And what's really cool about Empirica and the way we can design experiments for virtual labs is that every subject comes in and sees a pretty homogeneous type of experience. You see some leads on the side and a few collaborators. So if you didn't know any better, you'd think you were in a game with maybe 3 other people. And of course, you did see that 38 out of 40, which is also, I believe, Abdul, is that configurable? The 38 out of 40 piece?
Yeah. So everything in the lobby is configurable. You can configure from the logic of the lobby to the presentation of the lobby.
And that's important because you may not want people to know, depending on, of course, your scientific question. And then behind the scenes, there's some kind of, I assume, configuration or file that says who's observing whom. So James is observing collaborators 1 through 3 here, but collaborator 3 might be observing, 17, 12, and 11. So what you end up with is this behind the scenes management of information flow. So we're actually simulating like a society here, right? Everybody goes onto Twitter, they see their own followers. You go onto Facebook, so you see your own friends, but your friends and followers are seeing other people, right? It's that magic of interconnectivity that I'm just always blown away by. But what's going on here is that we're actually able to reconstruct this type of dynamic using Empirica. And it becomes actually really technically simple to do this. There's a part of the Empirica default scaffolding script that says, okay, how should we initialize the game? And somewhere in James's initialization script, which is pre-made by Empirica, all you have to do is modify that, make a little tweak. He says, okay, I'm going to read in for each user a list, and that's going to tell them who to follow. So all you have to do, you could type it by hand, you could use Excel, you could use iGraph, you could use Python, R, whatever your favorite network software is. You just make an edge list, feed that into your Empirica script, and it's just going to produce this behind the scenes network. And what you can end up with, it's not just about, oh, wow, networks are cool, but the idea is with these very simple configurations and script hooks, you can create incredibly complex interactions. In fact, it's not just about virtual laboratories being cheaper or faster. You can create things that wouldn't even be possible in an in-person laboratory. When I went, I'm just finishing up a postdoc at Kellogg, so I'll just share. When I went to the Kellogg in-person behavioral lab and said, I want to run a group of 40 people, they said, get out of my office, because it's not completely impossible, but the idea of doing these complex networks in an in-person lab is just a huge burden of complexity and cost and time and coordination. And then there's the fact that in reality, these networks don't exist in a single room. So it's not like virtual labs are somehow fake laboratories. We're actually able here to capture the way information is truly diffusing in an online space. But you look at James's screen and you see this very, very simple setup. So you don't have to pass any of that complexity onto your experimental subjects. So that's my little soapbox take. If you do have any questions about the design or how this game is playing, do feel free to chime in or shoot them to me in chat. And in the meantime, we can leave people who are seriously playing the game to try to solve the mystery.
And also potentially a useful exercise at some point for you, if you're thinking about using this tool, is to go to the website and check the community demos, and you will see that there is a wide range of very different looking experiments and feeling experiments about very different questions and different setups that are currently there. There are many more experiments that are not yet part of the community demo, but one thing that we try to ask is that for everyone who actually builds an experiment with Empirica, to share it with the world, just to also to expose to the world the variety of use cases. And even there are many use cases that we've never imagined as the developers of the tool itself. And very creative, imaginative way for people to use and put pieces together in order to kind of expand what can be done in those experiments. So James, like of all of the things that I see on the screen, how much of it is actually hard-coded? For example, I see the timer, the clues, the mystery, the collaborators, and how much of it is actually, if I wanted to change, will happen without adding any code, or it's not necessarily hard-coded?
So the descriptions here are hard-coded, as is the CSS and styling of all these pieces. The images are just referenced images, so there's a link that just tells you where to go. All of the clues are automatically generated for each mystery, as is the social network, as is the distribution of the clues, so which clue goes to which person. So those all happen and are randomized between every condition. whoever is playing my role in the other game will. So I see myself as playing in the control game right now, but there's somebody else playing in the treatment game. They're seeing the same neighbors, and that's because the code that procedurally generates the network is keeping that similar between the two conditions. And they also saw the similar set of starting clues that I saw and the similar set of collaborators starting clues. Now, from that point, everything diverges because we all make our choices through the game.
So assume that I like your experiment and I want to test other things that you did not test in your own experiment. So you have the independence and interdependence of clues, but what if I want to study the effect of the structure of the network or the time pressure? So I want people to actually make decisions within a minute versus 10 minutes, 3 neighbors versus 10 neighbors. How much additional programming will I need to do in order to run these experiments?
I had originally planned for today's game to be a 5-minute game instead of an 8-minute game. And I just forgot to set the parameter that changed it to a 5-minute game. And so that would have been very easy for me to do. The network structure is something I'm pulling in from Python. So changing a line in the Python script, which generates the network, and re-uploading, I'll show you the YAML files that I use later on, which construct those pieces. So now I've got to decide who did it.
So while you're all making your accusations, I want to follow up on a comment Abdullah made about how all the experiments look visually very different. That's not just a kind of cool thing. It's actually an important technical feature. So some platforms like Qualtrics, if you show me a Qualtrics experiment, I can tell you it was made by Qualtrics. And that's not just a personal aesthetic issue. What that means is that Qualtrics is constraining. So when you see a platform like Empirica that you can make 5 different experiments and nobody could tell you what platform you made it with, what that is a signal of is that it gives you complete flexibility. And especially as we start to consider how different visual design choices create attention distractions or might frame information in a certain way, things like the color or the layout or the setup can have profound scientific impact. So the ability for experimenters to control every little thing on the screen, at least for me, is something that's really important when I'm designing a study, because I want to know that the result I got is really what I want and not just something that turned out because it was too complex or difficult to design it another way.
And I think also to elaborate, it's not that you have the flexibility that I think is great to have, but also every decision you make, all of these little decisions you make are actually logged, recorded, and can be replicated and shared and modified with others. So they are kept track of. So at any point in time, you can revert back, but also you can see all of the decisions that you've made, including how did you convert the points from the game into dollar amounts for the workers. That is a decision to be made. It's not part of the implementation, it's part of the design. And then it is actually logged, and it's something that you can share. So you can export your entire experimental protocol, not just have people copy paste some code that you've written or just look at the data that you generated.
So now we've gotten to this point, I have a question for all of you who've played. Would you mind sharing with me in the chat window what your strategy was? So I'll share mine. This is the same thing that I put in the exit survey here. And then actually, if you'd like, also be able to share with me who you think did it and what condition you think you were in.
And remind us, what are the conditions that we're guessing between?
Right. So the treatment condition was the condition where there were clues that linked Bennett to the stolen object, or to the scarf, or clues that linked the car to the tool. And in the control condition, the clues that talked about Bennett talked about other things like his criminal record. I sympathize, Ben.
No, it's because Joshua's voice is very charming. You couldn't both focus on your game and listening to his deep voice.
What can I say? Bennett paid me off to throw in some distractions so nobody would figure it out.
Which is impressive, because he didn't know he was going to be randomized into this particular game. So after you've gone through the game, what the participants will see is the code that they need to submit on Mechanical Turk in order to claim their bonus. And so what I'll see now is that if I go back to my recruitment page, so this is Turk Prime again, I'll see that 37 different players have already finished and have submitted their code. If I go through and I have a look, I can see that most of them actually, these ones are all ones who got to play. And then here's a code that was submitted by somebody who went through the training screens, but wasn't able to get to the lobby before the game started. And so they got a code which said that the game filled up. And so I'll pay this person $1 for training, but they won't get the playing bonuses. And then let's see if we have anybody who arrived after the game had already launched. So here are a few people at the very end who they arrived after the game had already started. So they didn't even get to start training. And so they got a code which said that there were no games available. And this code, I will pay them 10 cents for showing up. But at this point, all they did was spend 30 seconds clicking into the link, seeing that they couldn't play, and going back. So that was the agreed payout.
So
go ahead.
Say I want to run another experiment, but I want to prevent repeat takers. So the ones who did it, I don't want them to take it again. What is that possible?
Yes. So Empirica keeps track of who's played. And because they're coming in with their Turk IDs, it's very easy to keep track of them. And that means that if you want to force individuals to only play once, you can. And there are other ways of letting individuals play multiple times or come back to a game at a later point.
Is there a way from the admin UI to actually see what information do we have and what happened to them?
Yeah, so what we have right here is all the players who have joined the server since I launched it on Wednesday. And so we'll see, this is basically where we start today. This is all you guys. There's me right there. And we're all idle. And then these are some of the Turk workers. And most of them have logged off already. Now, if I want to give them the ability to play again, what I can do is archive these players. So I would just select or retire the players, and select which set of conditions I want to retire the players from. And that's useful if a game cancels or there's a technical fault and you want to invite everybody back to play who didn't get to play the first time. So what I'll do now is I'll go ahead and...
I have a final
go ahead.
question.
Yes,
James,
please do.
Sorry, so if a player disconnects or drops off because of connectivity issue, their computer restarts and then they come back to the link, are they going to be treated like a new player or what's going to happen to them?
No, they'll continue where they left off. So I can do that for you right now. So here I am, I've finished the game. And let's say that I just close this window. Now I'm gone. And actually, if we go back to this players tab, we'll scroll down and we can see that I'm offline. Here I am, James is offline. And then if I come back to the same website, it's going to return me back to the same setting where I was. Are there any questions about the game at this point? Great. So who's interested in seeing your data? So what we'll do is I'll go to export, and I'm going to export this as a JSON line format because that's the format in the script that I've written. It does the analysis. And we'll download this. And while I'm going ahead and getting this set up, if there are any questions that you guys want to put forward, now's a good time.
It can be general questions. They don't have to be about the experiment in particular, just until he unzips the file and fires up the analysis code.
So I've downloaded this zip. I'm going to rename the structure to make it easy. And then I have to find my analysis code. Somewhere around here.
I have a question, I guess. So it seems like the Empirica really shines in this use case of multiplayer experiments. Are there other use cases like that this works well for? Like iterative learning experiments, or I don't know, other sorts of designs?
So the answer is yes. I guess one general way to answer this is that you remember that trade-off kind of thing. So if your experiment is a survey experiment, you could build it with Empirica because it's flexible enough to do that, but it might be an overkill for that experimental design. You're better off to go and do it in Qualtrics that is designed to do that. Similarly, for some of the other platforms, so some behavioral games, there are, if you want to run a Prisoner's Dilemma, there is already a platform that is designed for Prisoner's Dilemma. You just parameterize it. That potentially is the easy thing to do. The power comes from the flexibility, and then in the flexibility allows you to actually unlock the power of Empirica. So one is the real-time interaction, but you could make it discrete time, simultaneous or sequential. You can easily create these cultural evolution style of experiments where you have people come in at different times and they inherit solutions from prior participants and build up on top of them. You could build experiments that look like prediction markets. So people don't have to be simultaneously online at the same time, but they are working on the same instance, making predictions. If they are simultaneously online, they see each other's answers updating and the price updating in real time. But whenever you come in, you will see the latest state for the world that you are in. So it can accommodate all of these different designs. So the music lab experiment is something that you could implement here as well. So I think it's really when none of the existing tools can easily do the design that you have in your mind, Empirica is a good place to actually implement it. But then because there is an initial learning curve, like there is a steep learning curve at the beginning for any of these tools, once you are comfortable with your Empirica, then you have access to really a wider range of qualitatively different experimental designs that you could run.
So I have a question about that, Abdullah. Agreeing that Empirica could potentially be overkill for these independent kind of psychology experiments, which I think is a lot of what Molly tends to do as opposed to the group stuff. But it's a sort of, for me, very easy overkill once you're already set up. But I was wondering, Abdullah, if there's this idea that I think you mentioned briefly earlier is adaptive experimentation. This might be what Molly was mentioning. I'm not sure of all the terms, where you want to very quickly respond to the data that's coming in and tweak your parameters. It seems like Empirica is very well suited for that because of this ability to programmatically create and define factors. I'm just curious, honestly, I don't know much about this. Are there other platforms out there that can do this programmatic iteration for an individual experiment?
So yeah, this is actually another way actually to see that even for individual level experiments, so even for a survey experiment, for example, or an individual level decision-making experiment, Empirica can be really useful is when you need either like the participants to come at different, like multi-phase experiments where people keep coming back and they do different things at different times. So you want to keep track of who they are and what to do and what to show them next. Additionally, if you want to run adaptive experimentation, so this idea of procedurally generation of conditions. So if you want to actually optimize what to show them based on prior decisions, whether it's kind of within the same session or across multiple sessions, then it is a good way to, then Empirica allows you to easily do that. But also if you want to vary like the conditions that you want to sample for future participants, you run a batch of experiments, you show a stimuli, and then you get some data. And now you want to, for example, optimize what is the duration for the participant, what's the maximum duration that the participants can take in order to respond to what's presented in the screen. And you want that to be done algorithmically. something takes your data, runs an algorithm, looks at the data, and then decides, okay, the next experiment should have these conditions. And then you can just start that, and it's ready to use. Then Empirica is a good use case for that as well. And I don't know many other platforms that allows you to, for this like procedural generation of conditions and sampling of conditions algorithmically, except for one, Dallinger, but it's also for group. Usually it's optimized for group cultural evolution types of experiments.
Are there examples on the website of experiments that do this adaptive selection of stimuli?
So there are some ongoing experiments that are doing that. Is he with us today? No. So there is someone who's actually doing that. So individual level adaptive experimentation. It's not yet part of the community demos, although they promised to put it up as soon as they collected the data for their experiment.
Thanks.
But this is something that I intend to do also personally for a group experiment to vary the parameters algorithmically. And as soon as that is in place, it will and shareable, I'm going to share it too. But it's very easy. Like James actually can show an example for the conditions of his experiments are generated algorithmically, although not adaptively.
Not adaptively.
I can show you that to you now if you like. Let's just open this this project here. So the way I actually do this adaptive generation is I use the YAML file to set up the basic conditions for the game, and then I've specified the clue set in a JSON file. And so the first thing that happens is that when the game launches, this JSON file is read, and the clues are brought into the game, and it's the YAML file which tells it how to do that. So here is the code which generates the game. I can show you this here.
Can you maximize the size of the window so we can see?
And then let's just close some of these things too. You don't need to see that or those. You certainly don't need to see an Excel file in plain text. And I think I can make this a little bigger. So this is Python, my language of choice. You can use R or whatever you like. And it's a bit of a messy code because it's for me and not for public consumption. But basically what I do is I read in from this spreadsheet what are all the different parts of the clues. And then say this is a dictionary which is going to contain all the potential pieces, and I'm going to select randomly from that dictionary. And then I'm going to fill, so each clue consists of two endpoints. So maybe a name and a stolen object, and then a template which can be filled in. And so I fill in those templates. And then I tell the number of beliefs to distribute to each player and to randomly assign them to the different players. And then I create some factors which will be used in the YAML file. And I populate the YAML file. So this is a code to procedurally generate that YAML file, which will tell it what are all the different conditions that I need. So I'm going to have one factor, which is the number of bots in the game, for example. And then I just export that YAML file to a particular file name and all the configuration pieces. And then I have this YAML file. So I'll show you that. That's what this looks like. So I have a factor which says the number of players in the game, the length of the game in minutes, and all the other pieces. So this, if I was going to do an adaptively sampled game, what I might do is have a script which would take the results from my experiment and process those pieces and decide what are the next operating points that the experiment should be run at, and then to procedurally generate this new YAML file.
Yeah, so actually all the admin UI is doing is it's editing this YAML file through a graphical user interface. You are making decisions like what values to take. Empirica, all it does, it reads that YAML file, and that specifies to it which condition to run. And then it doesn't care how you're creating that YAML file. You could create it from a Python script, R script, it's adaptive, it's exhaustive, it's predetermined. It just reads in that YAML file.
Great. So before we run out of time, let's go ahead and look at your results. So what I've done here is again, I'm running in Python just because it's my most comfortable language. And what I've done is I've imported the export directory. So I called today's export directory Friday. And then I'm going to pull in data from, there's a players file, a games file, a treatments file, and a player logs file. And I'm just going to combine these into one big object. And what you'll see is I've actually got 3 different games here. So I've got a test game, which I ran before everything happened. I've got the game I ran for the session on Wednesday, and then I've got a game from today. So actually what I should have done is update this and then run all the rest of the cells. So let me just run all the cells real quickly here. Make sure we have everything run properly.
You got to admire the courage of anybody who does live coding.
Yeah, it's definitely one of the more intimidating parts of this job. So then what I'm going to do is I'm going to take the logs, and I create a big object which lets me analyze the logs. And now that I've logged all of the user actions, we can say, what do the 2 conditions look like, and how did each individual within the 2 conditions behave? So the first thing I'm showing you is just the total number of actions that each individual took in the game, either to categorize something as a promising lead or as a dead end. And on the left, you're seeing the treatment condition where the beliefs interact with each other. On the right, you're seeing the independent condition where they don't interact. So you see there's a huge amount of heterogeneity. And this is actually a really interesting piece of running the experiment, because in my agent-based simulation, all the agents are the same. But here, there are people who are taking 5 times, 10 times, almost 10 times as many actions as other people. And so this is one of the things that I need to test in my theory is, does this theory still hold when you have this heterogeneity between individuals? And this is something that I can get out of the experiment that I could never have gotten just purely based upon my agent-based model, because I wouldn't have known where to look. All right, now let's look at what fraction of the clues you guys thought were promising leads or dead ends. So it looks like on average, the independent case where beliefs did not interact with each other categorized 16 clues as promising and 9 as dead. And the treatment condition where beliefs interacted categorized about 15 as promising leads and 6 as dead ends. So it's interesting in that between games, you actually see these 2 flip-flop a lot as to who did more actions and categorized more things. And that's because there's a strong reinforcing dynamic at play in the game, which is that the more one person shares, the more their neighbors see, and the more that they can share. And so any sort of initial heterogeneity in the average level of participation between the individuals gets amplified by this condition. So this is another outcome of the game that I didn't see in my simulations. All right, now let's look at the which clues got shared and how they got distributed. See if I can make this larger. All right, let's do this one side at a time. So first we'll look at the interdependent clues. Now I'm going to share these images with you. You can think about them as your selfie take home from the day, because you're probably not going to be able to see much of the text here. But what I've done is I've taken every clue that was in the game. There's 78 different clues here. And I've plotted the number of people who have adopted them as promising leads and the number as dead ends. And some of the things you'll see is that many of the clues are categorized by some people as promising leads and others as dead ends. And actually, it's the ones that spread the furthest that are more likely to be categorized in both categories. Whereas some of these ones that don't really spread are just the ones that stay in one category or the other. The other thing you'll see is that I've got the clues sorted out so that the clues that connect to the crime scene and the stolen object are the end here. And in the treatment condition, we can see that there's a fairly reasonable balance between people who are adopting the clues that connect to the crime scene and the stolen object and the clues that connect to everything else, connect things to each other. But when I scroll over to the treatment condition, what you can see is that there's actually a huge weighting to clues that are connected to the crime scene and the stolen object. And people are less likely to share these clues that just tell you extra information about those individuals. So then the real question is, do these results support the theory? So first we're going to look through this. We'll say the first prediction that we made was that interdependence should increase the population's alignment along this left-right axis. And so to do that, I measure the principal component, so the first principal component of that population when I sort them into a parameter space based upon which clues they adopted. And you see that, yeah, this prediction is supported, borne out in this data. The next prediction was that the the distance between ideological camps, so this is represented by the similarity between the least similar individuals, should be lower in the treatment case, here marked with a T, than in the control case. And that was borne out as well. And then the last thing we see is that the 95th percentile similarity, which is the similarity within an ideological camp, should be greater in the treatment case than it is in the control case. And lucky for me, that bears out as well. So thank you all for behaving as you were supposed to and not throwing off the results of my theory. The worst is to have data that contradicts your theory. Now let's have a look and see who was idle. Was anybody in the game actually idle and see an idle message at any point? Just say yes in the chat or raise your hand or something. Abdullah. Several people went idle. That's okay. So the first thing that happens when you get an idle message is, well, basically what's happening is I'm tracking mouse activity. And when your mouse activity stops in the page, then for a whole minute, then you see this message. And in the message, some of you will know, I said, you know, if you become idle again, we'll not pay you. Now, of course, nobody does become idle again. And even if they did, I would still pay them because they're spending their time. But it's a nice way to get them back in the game. And then we can look at the survey responses. So how confident are people in their solutions? So the treatment case on average had 48% confidence, and the control case had 50% confidence. So we really don't see much significant difference between these two cases. And likely, in none of my cases do I see much significant difference between people who think that their whole team agreed with them and people who think that they were on their own. And then we can ask people, you know, was the pay fair? So we asked them these things. Did you have enough time? And what did you think of the game? Was there any problems? And then what were their strategies? Somebody said that they were sloppy in the game. All right, so I'm going to pause there with the data, and I'm going to stop sharing my screen. And the last set of time we have is for questions. So these can be questions about what I showed you today, or they can be questions about your own experiments or thoughts you have about what you'd like to do in the future. So please ask anything that comes to mind.
And as folks ask questions, I'd like to remind you that we're recording this session.
So I suppose...
Sorry, one thing to say is that we have 5 more minutes officially for the session, and we will be taking some general questions now that they are going to be recorded, but then some of us are going to stay along afterwards, and we can take some other questions and chit chats more privately.
And we're also in the process of figuring out good ways for community interaction. We're building a lot of documentation. We're working on figuring out like a Slack channel or something. So you can ask questions about that. There were some questions that came up in the chat about recruitment strategies. We're happy to talk about any of those things. Nicholas.
Yeah, sorry to come back to this, but so from what I understood, there are some costs involved in once you like deploy the experiments regarding, you know, the server that does the computing and the database. So for I don't know, a reasonably sized experiment that, you know, nothing too big, how much do they run up to? But yeah, just because that's like kind of an issue for teaching, for example, if you want to use them to use this and really like kind of get their feet wet, so there would be some costs involved in that. Did I get that right, or did I misunderstood you?
Should I take that, Joshua?
Sure. Yeah.
So, I mean, the experience might vary, so maybe it's good to actually hear from multiple of the people who used Empirica. And if you deploy the experiment to your private university server, for example, then there is no cost, right? It doesn't care where it actually lives. But if you use the setup that we've shown, which is MongoDB, Atlas, and Galaxy, then the thing is you can pause those services when you are not running the experiment. And it's relatively cheap. Like, well, I usually just deploy things on Atlas, MongoDB, on Atlas and Galaxy just because it's easy and convenient. And I pause the experiment when it's not running. And in a month, the cost for, I think the most expensive experiment I ran was maybe $70 a month or something like that. But a typical experiment will be $10 a month. And if you run it just like for classes or something like that, it would be much less, because like this experiment that James just demoed is like less than an hour and start to end for the participants, even if you had like multiple sessions within that hour. And then an hour on Galaxy and MongoDB Atlas, I don't know, it's like 10, 20 cents, something like that.
Yeah, so I'm looking at the services right now, and so the most expensive server you can possibly get from Galaxy is 16 cents per hour. And that means, you know, I always try to turn it off because I don't want to waste money, but if I run an experiment and forget to turn it off and come back the next day, I've spent like a couple dollars of my budget. And I'm looking at the database, and I have mine set to a fairly high tier, and it's 8 cents per hour. So for database plus server, we're talking 24 cents per hour. Just to give you a perspective, I've found that by and large, the far and above the largest costs for me are the Empirica fees. I always try to pay fair wages, which in Chicago is, I think minimum wage is $12 an hour. So,
yeah, we paid just probably about $100 for Turkers to play with us today. And when I run a full experiment, I'll pay something like $300 for a game in terms of Turkers.
And of course, the human subject participation kind of payment depends from experiment to experiment based on how, like the duration of the experiment, also the incentive structure, is it based on bonuses or not. Some more complicated experiments that are multi-phase. So for example, we run experiments where we bring in people, they do things individually, we tag their behaviors based on what type of people they are, and then they come back again and we put them in teams in a blocked randomization manner. So we create teams of all possible combinations of individual characteristics, and we have to have the people come back again a week after, so we kind of have to adjust the incentive in order to accommodate that. But people also have run experiments with Empirica with volunteers and just like playing games, and for those people did not, like the human subject experiment did not cost anything. It was mostly the hosting cost, and the hosting cost because they were volunteers, so they had the server up all the time, and it cost them less than $100 per month.
Could you say a little bit more about recruitment? Are there alternatives that folks use other than Amazon Mechanical Turk, or is that the sort of primary paid pool of workers that folks use?
So Empirica is agnostic to the pool of participants. It generates this URL, and then you can send it to anyone. Even you could run the experiment in the physical lab as long as you have the URL. I would say, as of now, the majority of use cases would include recruiting participants from Amazon Mechanical Turk and other crowdsourcing platforms, but even those are exceptions, and there's only one experiment with volunteers. But I typically run also experiments on my students in class, so that's also fun to do, although I don't use their data for publications.
So as we're right at time, I wanted to share with you, this is the Empirica website. It's empirica.ly, which is an easy one to remember. And in the website, there are many things, but one that will get you started quickly is this quick start. And we use this basically every time you run a game, start a new experiment this way. And the last thing I'm going to share with you is that the code for the game that we played today is going to be available to you at this GitHub repository, which is the Detective Game Demo. And this is a public repository, so you can go and you can see how everything's built up and how the conditions are assembled and how the game works.
And maybe to close off officially the session, let me just share a little bit of the future plans and what you can do for Empirica, in addition to what like most of the session is what Empirica can do for you. There is now the part where what you can do for Empirica. So just to remember, we have always this utility flexibility in mind. So Nicholas, the lead architect and software developer of Empirica, is our flexibility police. He does not allow us to add any features that actually can limit the imagination of our users and what experiments that they can run. And this is a kind of a hard trade-off to break off from. And we believe that the reason that one of the reasons why this actually trade-off exists is that all of the existing tools try to be an end-to-end solution. So when you run an experiment, there are so many different components, from specification of the experiment and the design, to the implementation, to the monitoring, to the recruitment, to the deployment. All of these very different aspects have to be operationalized and implemented in order to run your experiments. And each platform comes in and tries to actually implement all of them or provide all of them to the participants. And then that locks the people who use these platforms into the use cases that are imagined by the people who provided these components. So we think one way to actually make progress on this is to think about experimentation as an ecosystem of different components that can be provided by different tools written in different languages, in whatever language they like, as long as there is a protocol that allows these components to pass data to each other, to communicate with each other. You can stitch them together and then operationalize your experiment. So you can imagine that maybe you want to specify your experiment using the YAMLs of Empirica, but then you want to develop the experiment using JSPsych, and then you want to monitor it using your in-house built monitoring system that is built for your lab, for your specific use cases. You could just stitch in these 3 different pieces, and then that's your experiment ecosystem, or the tools of the ecosystem that you use to run your own experiment. So Empirica V2 is actually, which we are currently building, is actually built around this concept of an ecosystem. So we are building what we call an experimentation engine. So like in simulation, they have physics engines where you have just like the physics laws, and then you can simulate all types of physical interactions. The experiment engine will handle the timeline and the rules of experimentation and dealing with the database, but then that will be wrapped around an API. And any tool that speaks to that API will be able to talk to any other tool that uses the same API. So then we can actually create very different components, connect them to the API, and now these components put together, they can serve the functionality of the current Empirica. We call it Empirica V2, but it's really different components that if you put them together, you replicate what Empirica is. But if someone comes in and says, I like the callbacks to be written in Python, not in JavaScript, then all they have to do is to write a Python code that calls this API, and now you have Python callbacks that just you replace that one component, everything else will work in the same way without necessarily changing it. If you don't like the front end being in JavaScript or in the part in React, and you have another JavaScript framework, you could also do the same, or changing it to make it to work on mobile, for instance. So it's kind of this separation of concerns, and this modular ecosystem structure will allow us to integrate with other platforms, and then the entire Empirica will just be a tool in that ecosystem. But even if some components of Empirica dies out because technology changes or anything like that, we can easily replace that component without necessarily disturbing the entire ecosystem. So with that, I know we're 5 minutes beyond our specified time. Let's close it off here. And thank you very much again for coming.